Welcome to Mindset 100% Lessons, and in this video I'll be continuing from the previous lesson whereby I'll be explaining the function of reduction formulas in trigonometry. So remember, the main aim in this topic is to find the value of the different trigonometric ratios. For example, if maybe I want to find the ratio of sine theta, ratio of cos theta, or the ratio of tan theta, right? So if I can be specific with the angles, I can say I want to find the value or the ratio of sine 60, the value of cos 60, or the value of tan 60, right? I want to evaluate what is the ratio of these different trigonometric functions of a certain angle, right? So now, for us to evaluate these ratios, just to recap on the previous lesson, for us to evaluate these trigonometric functions, we have to make sure that our theta is actually less than 90 degrees. Therefore, this theta is an acute angle. Okay, so it means this theta ranges from 0 degrees to 90 degrees, right? So we basically want our angle theta to be in that range from 0 to 90 degrees. Okay, so now in the previous lesson I've explained that we have three different regions, right? The first region is from 0 degrees to 90 degrees. This is where we want our theta to be. Okay, so this is the region where we want our theta to be. But if the angle now is greater than 90 but less than 360, right? In this region, we have to make sure that we reduce all of these angles which are in this region into the first region, which is from 0 to 90, right? And the last region is angles which are greater than 360, which is this region. Okay, so in the first region we have theta, which is what we want, and in this region we have an angle which is between 90 and 360. So if an angle is in this region, we have to reduce it to the first region, right, which is from 0 to 90, and we do so by using reduction formulas, right? Okay, and then what if an angle is greater than 360? You reduce that angle by subtracting 360, right? So we basically want all our angles to be in the acute region, which is from 0 degrees to 90 degrees, right? So why is this region so important? The region is important because in this region we also find angles that the ratios of the trigonometric functions are known, right? And those angles, we call them special angles. Special angles are found in the region which is from 0 to 90. And which angles are those? So in that region, we have an angle of 30 degrees, which is a special angle. We also have an angle of 60 degrees, which is also a special angle. And lastly, we have an angle of 45 degrees, which is a special angle. Therefore, this means that we know the value of sine 30, we know the value of cos 30, and also the value of tan 30, right? Same applies to the 60 degrees. We know the value of sine 60, we know the value of cos 60, and we know the value of of tan 60 degrees. So the same applies to the 45 degrees. So these are the special angles, right? The trigonometric ratios of these angles are known, right? We already know these ratios. But then now, what do we use in order to determine the ratios of these special angles? We use what we call special triangles, okay? So the special triangles, we have two special triangles that we use in order to get the ratios of the special angles. So the triangles that we use are right angled triangle, two of them, right? So the first special triangle has 45 degrees on the vertices, okay? And then the second one has 30 degrees and 60 degrees, okay? So with the special triangle with 45 degrees, the side that is opposite 45, for example, this side, which is opposite that 45 degrees, is 1. So same applies to this other side that is opposite 45, is also 1, right? So if we were to use Pythagoras theorem in order to calculate this longest side, which is the hypotenuse in this case, we would get square root of 2, right? So this is our special triangle. It has an angle of 45 degrees on the vertices, and the sides which are opposite for 45 degrees, the length is 1, and also applies to this side, which is 1, right? But the hypotenuse is square root of 2, calculated using the Pythagoras theorem, okay? And then now we go to the second special triangle. The side which is opposite 30, right, which is this side, is 1. And the side which is opposite 60, which is this one, is square root of 3, right? And if we were to use the Pythagoras theorem and calculate the hypotenuse, then we were going to get a value of 2 for the hypotenuse. So these are the two special triangles that we use in order to determine the trigonometric ratios of the special angles, right? Like for example, let's say we wanted to find the ratio of sine 30, okay? We want to know what is sine 30. So sine 30, we use the special triangles, right? So that is the 30 degrees that we're talking about. And sine is opposite over hypotenuse, right? And the hypotenuse is 2 in this case. So it means sine 30 is 1, which is our opposite, over the hypotenuse, which is 2. So the ratio of this trigonometric function, if the angle is 30, is 1 over 2. But what if we want to find cos 30? Cos 30 is adjacent, the adjacent, which is this side, right, over the hypotenuse. Therefore, it would be root 3 over 2. And now tan 30, which is opposite over adjacent, then that would be opposite, which is 1, and adjacent, which is 2. Okay? Then that would be 1 over, oh sorry, no. The adjacent in this case is root of 3, right? Not 2. 2 is the hypotenuse. Therefore, it means tan theta would be 1 over square root of 3. Okay? So the trigonometric ratios of these special angles are known because we can use these triangles in order to determine the trigonometric ratios. Okay? So now let us recap on how do we actually reduce angles if they're in the third region, which is this region, or maybe the angles are in the second region, which is this region, right? We have to reduce these angles into the first quadrant or into the first region, which is from 0 to 90 degrees, okay? So now, remember the general rule says if an angle is greater than 360, right, all you have to do is to subtract 360 degrees. So for example, say I have sine 600, right? This angle is greater than 360. So what I have to do is to subtract 360. So this is the same as 600 minus, 600 degrees minus 360 degrees, right? And you will get sine 240. And now 240 is in the second region, okay, which is between 90 and 360. But whenever you see that your angle is greater than 360, then you just have to subtract 360 in order to reduce that angle, right? And you will reduce that angle into the second region or into the first region that we want. Okay, and then now, what if you have an angle that falls in the second region? Here, we concluded that you use reduction formulas, right? As I have stated up there. Okay, so now, how do we actually use those reduction formulas? We use our cast diagram. And in our cast diagram, I said we labeled our cast diagram like this. So it means here, cost ratios are positive, right? On the fourth quadrant, and on the first quadrant, all of these trigonometric functions are positive. And in the second quadrant, we have sine, which is positive. And on the third quadrant, we have tan, which is positive. So this means in the fourth quadrant, for example, sine is negative, okay? And tan is negative, which also applies to this region, whereby we'll say cos is negative and tan is also negative. And in the third quadrant, then we'd have sine, which is negative, and cos, which is negative, right? But then now, what are the reduction formulas that we have to actually use in these regions, right? So we have 0 degrees there, 90 degrees, 180, 270, and 360, right? So we basically want our angle to be in this region, which is from 0 to 90 degrees, okay? As stated in the first region up there. So we want our angle to be from 0 to 90 degrees. So in the cast diagram, we have 0 to 90 degrees here, right? We want all our angles to fall in this quadrant here. But then now, what if an angle falls in the second quadrant? How do we actually reduce this angle? We reduce this angle by 180 minus a specific angle, which is theta, right? And in the third quadrant, we reduce this angle by saying 180 plus theta, okay? And then in the fourth quadrant, we'd say 360 minus theta. So these are the reduction formulas, or these are the three reduction formulas that we use in order to reduce our angles into the first quadrant, right? All right, so let us have some examples. So example number one that I'll be doing is a bit longer, but it will show us all the steps that we need to follow when we're reducing angles, right? So the first example is tan 315 degrees plus cos 300 degrees divided by sine 150 degrees plus tan 135 degrees, okay? So now we have to simplify this expression. So since this is trigonometry, the first thing to do, we have to identify or locate your angle, right? Where is your angle? So if you locate your angle and then you find that it's greater than 360, so you know how to reduce it. You have to subtract 360, right? But if you locate your angle and then you find that it's between 90 and 360, that is where you use your reduction formula, right? Using the cos diagram. Therefore, it means your angle is between 90 and 360, all around to 360. So you're going to have to use one of these reduction formulas in order to reduce it into the first quadrant, right? So you locate your angle. After locating your angle, you choose the correct reduction formula in order for you to reduce that angle into the first quadrant, right? All right, so the first example, which is tan 315. So let's locate this 315. 315 is actually in the second region, right? Because 315 is less than 360, but it's greater than 90. So it's in the second region. And in the second region, we use reduction formula, right? So in our cos diagram, where is 315? 315 falls in this quadrant, which is the fourth quadrant, right? Because it is greater than 270 but less than 360. So 315 is in this quadrant. And our reduction formula is 360 minus theta in the fourth quadrant, right? So we're going to rewrite this as tan 360 minus a specific angle that when we minus, it must give us that 315, right? So that would be 360 minus 45, okay? So 360 minus 45 will give us 315, okay? Plus, let us follow the same steps for the second expression. So cos 300, so we have to locate where does 300 fall, right? We see that 300 falls in the second region, whereby we have to use reduction formulas, okay? And in the cos diagram, where does 300 fall? Still, it falls in this region, right? So it means we'll use this reduction formula. So that would be cos 360, because we are using this reduction formula of 360 minus theta, right? That would be 360. And then what do I have to subtract in order for me to get 300? I would have to subtract 60 degrees, right? And now divided by sine 150. So where does 150 lie in these three regions? 150 lies still in this second region, whereby we use reduction formulas, right? But on our cos diagram, it lies in the second quadrant because 150 is greater than 90, but it is less than 180. So 150 lies in this region. And what do we use in the second region or in the second quadrant? We use 180 minus theta, right? So that would be sine 180 minus, so what we have to subtract in order to get 150? That would be 180 minus minus 30, right? That would give us sine 150. So now the last part, which is tan 135. 135 still falls in the second region, okay? It falls in the second region, and in the cos diagram, tan 135 falls still in this region, right? Which is the second quadrant. So in the second quadrant, we'd still use 180 minus theta. So that would be 180 minus 45 degrees in order for us to get 135, right? So now we have to check the sign of each trigonometric ratio in each quadrant. So as I've stated that cos is positive in the fourth quadrant, right? Then it means sine and tan should be negative, okay? So now let's see. This is a reduction in the fourth quadrant, and in the fourth quadrant we said tan is negative. Therefore that would be negative tan 45, right? We have now reduced this angle, okay? Plus, and we said cos is positive, right, in the fourth quadrant, and 360 minus theta is in the fourth quadrant. Therefore cos should be positive. Therefore it will stay being positive, right? So that would be cos 60 divided by 180 minus 30. This is in the second quadrant, right? And in the second quadrant sine is positive. Therefore that would be positive sine 30, okay? And then now this is also in the second quadrant. 180 minus theta is the second quadrant, and in the second quadrant tan is positive, right? No, tan is negative actually, only sine is positive. So tan is negative, therefore we'd get negative tan 45, okay? So now we can see that we have trigonometric ratios of special angles. 45 degrees is a special angle, 60 is a special angle, 30 is a special angle, and 45 is a special angle, right? So now we have to go to our special triangles and try to evaluate what is the trigonometric ratios of these special angles. So tan 45, okay? So if we go to the special triangle tan 45, which is opposite over adjacent, then that would be the opposite, which is 1, and the adjacent, which is 1. So that is 1 over 1. So tan 45 is 1, right? Which is the same as 1 over 1. Okay? Plus cos 60. So cos 60, let's go to the special triangle, the second one, cos 60. So this is the adjacent, which is 1, and that is the hypotenuse, which is 2. So it's adjacent over hypotenuse. So adjacent over hypotenuse, that would give us 1 over 2, right? And then divided by sine 30. Sine 30, that would be opposite, which is 1, over 2, which is the hypotenuse, right? Then that would be 1 over 2. Then it means sine 30 is 1 over 2, plus negative tan 45, and we already said that tan 45 is 1 over 1, right? So that would be 1 over 1. So if I can simplify that, that would be negative 1 plus 1 over 2 over 1 over 2 minus 1, right? And negative 1 plus 1 over 2, that would be negative 1 over 2, and 1 over 2 minus 1, that would be negative 1 over 2. And if I divide this, I would get 1. So the answer to this expression is 1, right? So what we did is we located the angles and tried to find which region does it belong to. If it belongs to the second region, which is this region, we use the reduction formulas in order to reduce it into the first quadrant so that we can evaluate it.